All right, we're going to do solving systems algebraically. Try and get these notes in quick. Again, this is a review section from Algebra 1. Let's just do a little bit of graphing since we just did that in 6-1. So we're going to solve the following linear systems by graphing. We're going to flip both of these into slope-intercept form. I'll take that first equation, 8 minus 3x. I'm going to move those around so my negative 3x is coming first. Then, Ray, what do I need to do? Did that. Divide everything by 4. So I get y equals negative 3/4 x plus 2. That's one of my equations. And then let's bring down our y minus x equals 1. What do I need to do? Move that x to the other side, and it's going to stay negative or go positive? Go positive. All right, so let's graph those. So we've got 2, and then we're going to go down 3 and over 4. Let's see if I can still draw a straight line. Whoop, well, pretty straight. And then we're going to go up 1 and over 1. So our solution is actually somewhere in the middle here. Yeah, that's going to be a solution. Okay, so the problem with that is not very accurate. Our solution's out here in the middle somewhere, but not accurate. So graphing is great, and it definitely has its purposes, especially when we get into linear programming, but it is not the most accurate way to graph. Or sorry, accurate way to find a solution to a system. So that's when we need a different way to do it, and we're going to use our algebra skills to do that. So one is by substitution, one is by elimination. I will tell you that hands down, I prefer elimination over substitution. I think it's much easier, much more straightforward than substitution, but it depends on the situation as well. Substitution is used best when you already have one of the variables isolated, or you can easily get it isolated. Elimination really works best when the variables are lined up, basically when they're in standard form. So you might want to add that here. This would be a standard form way to solve, and this would be a slope-intercept way to solve, typically. Slope-intercept form. Okay, so let's use the substitution first. So anything that I have that I can easily get, a variable that I can easily isolate. So which variable do you want to isolate, Ray, on that second equation, the y or the x? The x, okay. So how would you, see now I would have chosen the y only because it's already positive and I don't have to deal with a negative. But either one works, so let's go with x. So how do I get that x by itself? What do I have to move? The y, good. Is it going to stay positive or go negative? Go negative, right? We're going to move it over there. But now I've got negative x, what do I want? Positive. So how do I do that? How do I flip all those signs? Multiply by negative 1. So I get x equals y minus 1. Once I have that, then I'm going to use this lovely little word called substitution. So in that other equation, anywhere I see an x, what am I going to substitute for the x? How about that whole thing? These two are equivalent to one another, right? So anywhere up here that I have something orange, I can put another thing that's orange as well. So instead of the x, what am I going to use? Y minus 1, because those two things are equivalent, right? It's like swapping out one kind of cheese on your sandwich for a different kind of cheese on your sandwich. It's still cheese, just looks different. It's making change, right? So I want you guys to think about that when you're doing substitution. You're making change. So if you have a $20 bill, you could also have 4 5s. You could have 21s. You could have 2 10s. You could have 2 rolls of quarters. You could have lots of different things, okay? By doing that, what happened to our x? Is it there anymore? It magically disappeared, which we really, really like. So now we're going to go ahead and solve that out. Ray, do I subtract 8 and 3 first? No, I do not do that. You distribute first. Good. 8 and, so distribute that for me. Beautiful. Okay. And now we need to get what where? By itself. So how am I going to move that y over? I'm going to add it, and then 8 plus 3 on the other side is what? 11 equals 7y, and then what do I do? Divide by 7, which is kind of an ugly fraction, but that's okay. We can keep it just like that. We knew over here it was somewhere ugly, right? We knew it was not a pretty graph. Okay, and so then once I have a y value, my advice would be to write a coordinate pair next to every problem that you do so it reminds you that you need an x and a y. You can eliminate that. And then how would you find your x, Ray? Plug it in, and I'm going to plug it in. You can plug it in either equation, but I use one to solve and the other one to check. So x equals, now I have a value for y of what? And minus 1. How many sevenths would I have if I had 1? 7. So that'd be the same as 7 over 7. Might as well turn everything into fractions, and we get x equals 4 sevenths. And if I go back and look at that graph, that means I'd be kind of halfway in between 0 and 1, and then halfway in between 1 and 2, and that's about where that point is. Except this algebraic method is completely accurate, where our graphing method is kind of a sort of accurate-ish, but really not accurate. Okay? So anytime you have a variable isolated, or you can get it easily isolated, you're going to use substitution. So let's go down to example 2 at the bottom, and the print's a little bit small, so I'm going to zoom in there. All right, Ray, so what do you want to substitute for what? What, let me ask you this way. What variable do you have isolated? Y. So the y is equal to the 2x minus 9, correct? So if orange equals orange, then what would that y down there also equal? The 2x minus 9. Good, so we could go y negative 3x equals negative 15 minus, so instead of y, I'm going to swap it out. I'm going to make change for the 2x minus 9 because I know that they're equivalent, they're equal to one another. Okay, and now we just need to distribute. When you have a negative in front of a parentheses, it's like distributing a negative 1. Good. So we get negative 3x equals negative 15. Go ahead and distribute for me. Wait, right, what? Yes. There we go. Okay, and where do we want to move things? Okay, tell me what. Good. Add 2x, and then we'll get negative x equals, what's negative 15 plus 9? Negative 6. So if negative x equals negative 6, what does x equal? 6. Good. Put your little coordinate point over here so you remember. And then where are you going to plug that into? Is there an equation that we started with that already had y isolated by itself? Yes. So since we need to figure out y, that logically is the easiest one to plug into. So y equals 2 times what? 6. Good. Minus 9. And 2 times 6 is 12. Minus 9 is 3. Good. So our point should be 6, 3. Are we going to check our work to make sure that that's correct? Of course we are. So since we used that top equation to solve for y, let's use the second equation to check our answer. So negative 3 times 6 is what? Negative 3 times 6. Negative 18 equals negative 15. And since it's negative y, what's the opposite of our y? And what's negative 15 minus 3? What's negative? What? What? What's negative 15? Negative 18. That's what I thought you said. Oh my goodness. I think it's time to go. All right. And that checks out. So 6, 3 will be our solution there. All right. Let's do one more. Get us out of here. Okay. So, Ray, what's an easy? Pick a variable that you want to get by itself. One that would be really easy to get by itself in one little step in either equation. Really? Could do y, but it's going to take you 2 steps. I'm challenging you to find the one that's going to use 1 step. X. What equation would that be in? The first equation or the second equation? Second equation. Good. Because here's x. So what's the only thing I need to get out of the way to have x by itself? The y term, right? That one, right? The 8y. So when I move that to the other side, is it going to stay 8y or go negative? It's going to go negative. Good. So I would have x equals negative 8y plus 10. So now that I have that, what can I do with that negative 8y plus 10? I can substitute it for x in the other equation, right? So negative 3, what's my x equal to? All of that, right? Negative 8y plus 10, then minus 1. Now I'm just adding in the rest of my equation equals negative 30. Do I have any x's in this equation now? Nope, they magically disappeared, which is what I wanted them to do. So are we understanding that concept? Everyone, not just Ray. That when things are equivalent, you can substitute them for one another. So down here in the, or sorry, up here, I had an x, which we can color orange, but instead I'm going to plug in my other orange, which is my negative 8y plus 10, meaning all the x's go away, and then we can just solve. So do that distribution for me. 24y minus y equals negative 30. Beautiful. And then what's 24 minus y? 24y minus y? 23y. Good. And then how do I get that negative 30 to the other side? Got to add it. Well, that's happy because what's negative 30 plus 30? 0, and 0 divided by anything is 0. For y value is 0. Let's put that up here. Oh, well, x should be pretty easy to figure out now, yes? So we're going to use this here. And x, actually we can use this one that we isolated. It's x equals, what's negative 8 times y? Or sorry, what's negative 8 times 0? Sorry. Plus 10, what's 0 plus 10? 10, so that value should be 10. Let's check it in the other equation just to be sure. What's negative 3 times 10? Negative 30 minus what's our y value? What's negative 30 minus 0? Negative 30. Beautiful. Happy Friday afternoon. That's the end of that. Okay, so that first section was solving linear systems by substitution. Now we're getting into elimination, which frankly is my preferred method. I think it's much easier, much more straightforward. And what you're actually doing, you can sometimes this will be called combination also. It's really both combination and elimination. It's combination with the goal of eliminating one of your variables. So you're going to stack your equations so that you have your x's lined up, your y's lined up, and your constants lined up. Once you do that, the whole purpose is to eliminate one of those variables, which means you need to have positive and negative of the same term. Because then when you add those together, they will equal 0 and they will be eliminated of the same term. So let's start with our example here. We could ask Mr. Pochop. He's going to help now too. So, Mr. Pochop, do my x's eliminate each other? No. They do not. Do my y's eliminate each other? Oh, happy day. So, we're going to, it's glorious. So what is 2x minus 3x? Don't get this wrong. It'd be really embarrassing. Ah! Negative 1x equals, and 9 minus 15 is negative 6. Do I have x by itself? Kind of, sort of, yeah. So x equals 6. Remember to always write your answer as a coordinate pair. Kind of reminds you that you need both parts. And then which equation would you like to substitute back into? The first one. I always say use one to find your answer and the second one to check. So what are we going to substitute for x? 6. Oh, you had to think about that. Minus y equals 9. So what's 2 times 6? And when we move that to the other side, does it stay positive or go negative? It goes negative. 9 minus 12 is, so then if negative y is negative 3, y is 3. Stupendous. So then that's our answer. Now, Raymond, what are we going to do? How are we going to check it? We use the first one to solve? Good. So what's our x value? 6. And what's our y value? Oh, we got a little oh, no, we're okay. Oof. Thought we were going to have another issue. What's negative 3 times 6? Negative 18 plus 3 is what? And that checks out, so that is right. So I'm not lined up. That usually happens. They know. There we go. Okay, so let's go to example 5. So this was nice that our y's were just negative y and positive y, and they were really easy and very cooperative, but of course life will not always be so cooperative. So you go with the same idea. What is our x terms, do they cancel each other out? Anybody? No. Do our y terms cancel each other out? No. So we have to make them cancel each other out. So Ray, which variable would you like to eliminate? That's the question you need to ask yourself, and it absolutely does not matter which one you choose. Doesn't matter. Which variable do you want to eliminate first? And you said y? Okay, excellent. So we have an 8y and a y. What would I need to have to eliminate that 8y? I would need a negative 8y, right? So this whole equation I'm going to multiply by negative 8. So let me pull that top equation down. And then what would I get for the second equation if I multiply everything by negative? Good. Yes. Oh, da da da. There, good. There we go. Now when I add my two equations together, or when I combine my two equations, do my y terms eliminate? Oh, happy day. What's negative 10 minus 24? Negative 34x. And what's negative 120 plus negative 116? Or sorry, negative 16? Good. And then we're going to divide by negative 34. And so our x would equal 4. Put your little coordinate up. And then once you have that x value, how are you going to figure out your y value? You could do the top equation. What equation is even easier to plug it into? Because now you have choices, right? Now you've actually got 1, 2, 3 choices as far as which equation to plug into. I like the easiest, but you can go difficult. It's all good. Half of my class will, because that's what they do. Second equation. Okay, so we have 3. What's your x value? 4 plus y equals 15. What's 3 plus 4? 12. And 12 plus what gives you 15? So our y value is 3. Should we check our answer? Of course we should check our answer. Never! That would be crazy. Let's see. So negative 10 times 4 is what, Raymond? Oh, Mr. Pochop can do it. All right. No pressure. Negative 40. And 8 times 3 is 24. And negative 40 plus 24 is? Oh, and happy day, it checked out. Excellent. All right, now we lost Mr. Pochop. He gave up, so now it's just Raymond and I again. Okay, so first of all, Raymond, do you have all your x terms lined up and your y terms lined up? Well, you kind of do. Look at the signs in between. Oh, they played a little trick on you, didn't they? And remember you want it in standard form. So what needs to come back over? So that you have x and y on the left-hand side of your equation and only your constant on the right-hand side. Y over, and when we move it over, is it going to stay positive or go negative? It's going to go negative. So now if I just scooch that over, that's fine. But are they in the same order as my other equation? Now, so let's just flip around. So we would get 10x minus 2y equals 22. Oh, well, that's kind of helpful. What happened? Exactly. Now you're able to cancel because they are opposite signs. So x plus 10x is what? 11x equals 33. So x equals 3. Good. And which equation do you want to plug that into? Hey, that's a good idea. So we get 3 plus 2y equals 11. How do I move that 3 over? Subtract 3, which gives me what? 8, and 2 times what gives you 8? 4, so that should be a 4. And of course we're going to check our work, aren't we? Yes, so 10 times 3 is what? 30. And 2 times 4 is 8, plus 22 is, and that checks out. Beautifulness. Okay. Good. Let's go to 7. Eek! Fractions, the bane of our existence. We don't want those, do we, Raymond? So how can we get rid of those fractions? Use, say it, fraction busters. Yes. How are we going to bust that fraction? We are going to multiply, what do you get if you multiply your denominators together? You get 6. So I'm going to use 6 to get rid of everything. Okay? So I'm going to multiply each of these by 6. Because as long as I can multiply the entire equation by the same thing, I'm not changing the value of the equation at all. I'm not changing what that equation is. So I'm going to pull my first equation down, negative x minus, equals negative 11. Let me try that again. That didn't work. Actually, let's move that around. Okay, do we have our x terms on the left side, x and y on the left side, and our number on the right? We do? We have x and y on the left-hand side of the equation. Oh, there we go. Yeah, the bottom one's okay, but it's just got fractions going on. So what do we need to move out of that first equation? The y. So when negative 4y goes to the other side, is it going to stay negative or go positive? Going to go positive. So let's just scooch him over there, and at least we've got that. And let's go ahead and put our x term first, plus 4y equals negative 11. Now let's deal with our fraction busters. So if you have a 3 and you get to 6, what do you need? You need to multiply it by 2. What's negative 2 times 2? Negative 4x. Good. You have a 2, what do you need? You need a 3 times 1. Good. Equals a negative 1 times 6 is negative 6. So, do your x terms cancel out? Do your y terms cancel out? Can we make one of those terms cancel out by multiplication? Which one would you like to make cancel? Which variable would you like to cancel first? X. Good. What's the opposite of negative 4x? So what do I need to multiply that negative 1 by to get positive 4? Negative 4. So we're going to multiply that entire equation by negative 4 and then swing it down there. So what's negative 4 times negative x? 4x, which is what we wanted. What is 4y times negative 4? Good. And negative 4 times negative 11. 44. Good. All right. Let's see what we've got. So, what happens to our x term? They cancel out because they're opposite signs. What's negative 3 minus 16? Negative 19y. And what's 44 minus 6? Did you say 38, Ray? I thought you said 38. Very nice. That's okay. And then what do you divide both sides by? And then our y would equal negative 2. Let's put our coordinate point out there. And then what? Well, not yet. Got to plug it in to solve for x, right? So now you've got 1, 2, 3, 4 equations you could use to solve for x. The very one up here? Okay, so we get negative x equals negative 11, and that was originally negative 4y, right? Yes. Minus 4 times, what's your y value? Negative 2. What's negative 11? What's negative 4 times negative 2? 8. So negative x equals, what's negative 11 plus 8? Negative 3. So if negative x equals negative 3, then x equals 3. So x equals 3. Are we going to check our answer? Oh, of course we are. Let's even check it in the fraction. Let's really go crazy and check it in the fraction. So negative 2 thirds times 3 minus 1/2 times negative 2 should equal negative 1. What do the 3's do to each other? They cancel out. So that gives us negative 2. What do the 2's do to each other? Cancel, and a negative times a negative is a positive 1. What's negative 2 plus 1? Negative 1. Could we have used one of the other equations to check that? Which one? Top, bottom, middle, any of them, right? Let's check that one. Negative 4 times 3 and negative 3 times negative 2 should equal negative 6. What's negative 4 times 3? Negative 12. What's negative 3 times negative 2? Plus 6 equals negative 6, and that checks out. Beautiful. All right, let's do the last one. Example 9 and 10 are going to be done independently by my eager Algebra 2 students who just cannot wait to get to the part where they're doing this independently. But you're pretty sure none of them are eager? That's probably the most accurate thing you've ever said, right? Okay, so do my x term, oh, hello, let's get on the right problem. There we go. Do my x terms cancel out on number 8? Do my y terms cancel out? So, do any of my x terms, would they easily cancel? Like, can I put one into the other? No. So now I've got to find essentially what's the common denominator, right? You've got to find a number they both go into. So do you want to eliminate your x's or your y's first? Okie dokie. And what's the number that 4 and 5 would go into? 20. So one of them needs to be 20, and one of them needs to be negative 20. Yes? So what I tend to do is write them over to the side, or we can write them below so we have a little bit more room. We need a 20x and we need a negative 20x. So let's make this our top equation. So to get negative 4x to become positive 20x, what do I need to multiply everything by? Negative 5. Good. Erase those zeros over there. And just to be sure that you don't forget any, I actually really prefer that you write them above just like this, because while I know you know distributive property and all of that, something always gets forgotten. It's just the way that it is. So if you write it right underneath, it's harder to forget, and right above, it's harder to forget that number. Negative 5x would become negative 20x by multiplying by how much? 4. Good. So we're going to multiply each of those by 4. So go ahead and give me a new equation for the top. Good. Perfect. And the second equation? Good. So now, do you have a term that cancels? Our x term cancels because that's the one you chose to make cancel in the first place. And what's 28 minus 25? What? I know. And then 20 minus 5? 15. So y equals 5. Good. And then now you've got 1, 2, 3, 4 choices. Look at all the choices and options you have to solve for x. Which equation do you want to use? Top one. Okay, so we have negative 4x plus 5. What's your y value? 5 equals 1. So negative 4x, what's 5 times 5? 25 equals 1. How would I move that 25 to the other side? Subtract it. So let's get that out of there. Negative 4x equals negative 24. So what does x equal? 6. Good. Are we going to check our work? Of course we are. So which equation do you want to use to check? 1, 2, 3. Since we used 1 to solve it, use 2, 3, or 4 to check it. 2. Okay, so what's negative 5 times 6? And what's 7 times 5? 35. And what's negative 30 plus 35? Should equal 5, and it does, so we know we got it right. Excellent. Okay. For numbers 9 and 10, I'm going to let you work on this independently. We'll check the answers in class, and not only do I want you to choose the best method to solve them, whether it's substitution or elimination, but that I want you to use the method you choose to solve your equation. Okay, that's 6-2. Make sure there's not another page. Oh, there is. We'll do the rest of 6-2 in class along with the practice. And then we're actually going to have a section 6-2-A, which is solving systems with 3 variables, which I neglected to put in the note pack. So I'm going to add an additional couple of pages to your note pack, and we will do that next week. So there you go.